up an equation for acceleration down an inclined plane where there is friction. So I'm going to have an inclined plane at a certain angle. Here's an object. And I'm going to have a normal force working straight out. I'm going to have weight cosine theta working in. I'm going to have weight sine of theta working down. And I'm going to have friction working back the other way. Now you'll notice I'm not going to make it as long as this one going down because I know that this object's supposed to be accelerating downwards. I'm going to figure out what that equation is. And if this is the case, my common sense equation I need to start with is that I need some net force. There has to be net force. And how do I figure out that net force? Well, it would equal mg sine of theta, which is the force going down, minus friction force. I should subtract friction force, and I should still have some net force left over. So that's the premise we can start with to start deriving an equation for acceleration. So what is F net? F net, according to Newton's second law, is always ma. And that would equal mg sine of theta minus friction force. What's friction force? Well, that is mu Fn. That's the equation for friction. So that would be ma equals mg sine of theta minus mu, and Fn, of course, in this FBD would actually equal mg cosine of theta. This up force and that down force should be equal. So mu times mg times cosine of theta. And you'll notice that there's a mass in every one of these terms. And so I get an equation, acceleration equals g sine of theta. We stop right there for a second. That's interesting because that was the equation in our last video for a frictionless inclined plane. When there's no friction, the acceleration is g times sine of theta. When there is friction, we have to subtract off a little bit. We have to subtract off minus mu g cosine of theta. So clearly acceleration down an inclined plane with friction is not going to accelerate as fast as if there's not friction. So really this is the equation for acceleration down an inclined plane. Without friction is kind of a unique example, which we never have, but if we did, if there's no friction, then what does that mean mu is? Mu is 0. So this whole last term here would be 0, and our equation would collapse to just acceleration equals g sine of theta. So that first part of the equation is for a frictionless inclined plane. This whole equation here is for a normal inclined plane where there is friction. So you can plug in whatever numbers you need and solve for whatever you would need in this particular problem. But that's the equation for acceleration down an inclined plane that has friction.